Hey everyone and welcome. Today we are getting our hands dirty, so to speak, and diving into the modern car fixing playbook. We're going to look at the new rules for figuring out what's wrong with the incredibly complex machines we drive every single day.
So, let's kick things off with a question that, honestly, sounds kind of weird. Why would your transmission problem also be an engine problem? I mean, you take your car in for a shifting issue, and the mechanic starts poking around the engine. It feels like two totally separate things. But as you're about to see, in today's cars, they're not separate at all.
And figuring this connection out, it isn't about guesswork. It's not just swapping out parts, hoping the check engine light turns off. Nope. There's a specific, systematic playbook that a skilled technician has to follow to solve these modern puzzles.
We're calling this first part Ghost in the Machine. And for good reason. Imagine a customer says their transmission shifts hard, but only when the rear defroster is on. It makes zero sense, right? These are those mysterious, intermittent problems that feel like a ghost, and to find that ghost you have to know the very first play in the book.
And that first play, well, it all starts with one core idea. Modern cars don't have a bunch of separate brains doing different jobs. They basically have one big, integrated system that shares absolutely everything.
What's so cool about this slide is just how different things are now. Back in the day, in older cars, the engine and transmission were pretty much strangers. They did their own thing, had their own controls, and barely talked. But now, in modern cars, they are in constant conversation, sharing data and making decisions together, like a single unit.
So how do they talk? They use something called the CAN bus. And the absolute best way to think of the CAN bus is as the car's central nervous system. It's this complex network that lets the brain of the engine, the ECM, and the brain of the transmission, the TCM, chat back and forth in real time. And this table right here, this shows you exactly how connected they are. Just look at it. A sensor like the one for your throttle position. It doesn't just report to the engine, it sends that exact same piece of information to the transmission at the exact same time. Same thing for vehicle speed, same thing for the crankshaft. They're all sharing. So here's the kicker. This is why it all matters. If just one of those shared sensors starts to fail, it can send garbage data to both the engine and the transmission. This can set off fault codes in both computers, making it look like you have two completely different problems when it's really just one. A mechanic who doesn't get this could end up wasting a ton of time and, let's be honest, your money. Okay, so that brings us to our next section, the digital detective. Now that we know all these systems are interconnected, how does a technician actually pinpoint that one single root cause? Well, they follow a very specific diagnostic strategy.
It's a really clear three-step process. Step 1, they read the map. That means they look at the vehicle's wiring diagrams to see how it's all put together. Step 2, they interrogate the system using a scan tool to see what it's doing right now. And Step 3, this is the really cool part. They replay the crime using something called freeze-frame data.
So what in the world is freeze-frame data? Think of it like the black box flight recorder on an airplane. The moment a fault happens, the car's computer takes a perfect snapshot of everything that was going on. The vehicle speed, how hard the engine was working, the temperature, at that exact millisecond.
And the value of this is just huge. Especially for those super frustrating problems, the ones that seem to disappear the moment you pull into the shop. This data is often the only piece of evidence a technician has to figure out the exact conditions that caused a problem, letting them actually find it and fix it for good.
All right, now, before a technician even thinks about picking up a tool, we have to talk about the single most important part of the playbook, safety. Because under the hood of any modern car, there is a high-voltage danger zone.
Take a look at this number, 40,000. That is a big number, and it represents a very, very real danger that's just lurking under the hood. What on earth could it be?
That is the number of volts that can be running through a modern car's ignition system. Yeah, that's not a typo. 40,000 volts. This is absolutely not something you can mess around with.
And the dangers aren't always the ones you'd expect. Sure, there's the high-voltage ignition system and high-current wires, but look at that last point, jewelry. A simple metal wedding ring or a watch can instantly become a perfect path for electricity, causing a serious burn in less than a second.
And let's be perfectly clear on this. Following these safety rules isn't just a good idea. It's not a friendly suggestion. For a qualified technician, it is a mandatory, formally tested skill. Proving they can spot and control these risks is a fundamental part of their job.
Okay, so the fault has been found, the new part is in, and it was all done safely. The job's done, right? Well, not quite. And that brings us to the final and most critical section of the playbook,
proving the fix actually worked.
And there is a huge difference between a job that's just done and a job that's done right. See, anybody can plug in a scan tool and just clear the fault codes, wiping the car's memory, but a true professional confirms the repair with a dynamic road test, putting the car through its paces in the real world.
So why is this road test so critical? Because some faults are sneaky. They only rear their ugly head when the engine and transmission are working hard together, under a real load, out on the actual road. A test in the workshop might miss it completely. The only way to be 100% sure is to drive it.
So, the final checklist for a professional repair is pretty thorough. You clear the codes, sure, but then you do both static and dynamic tests. You have to confirm the fault is really gone when the car is working hard. And finally, you document everything, what you found, what you did, how you tested it, on the repair order. That's how you properly close the loop. So, this really leaves us with one final thought. The next time that check engine light pops on, ask yourself this question. Are you looking for a parts changer? Someone who just guesses and swaps components? Or are you looking for a systems analyst, a skilled detective who truly understands the playbook for the complex, integrated machine you depend on every single day?